All right, thanks, Katie. What?
It wasn't on all the way.
Oh. Well, it's fun to
take it
be
away, David.
on this side of the camera. Usually I'm the one being it. I want to cover just a couple of subjects today, both kind of in the framework of OpenStudio, and talk about some of its potential. If you haven't used it before, OpenStudio is kind of, it's NREL's front end to Energy Plus. It's been around since about 2010, has about 20,000 users. So today in OpenStudio, I want to talk a little bit about how we construct a radiant HVAC system. I'll do a quick demonstration on that. And then they're developing some new calibration tools within it, and so we'll talk a little bit about that. I'll give a demonstration on that as well, where you can actually import your building's utility data and get a very quick visual to see how your model is performing in comparison to that. And lastly, I want to link that with what's recently launched from them, their Parametric Analysis tool, where you can run hundreds of simulations very, very quickly, change lots of different variables, and then see how that affects your calibration. So why use OpenStudio? Like I said, it's the front end for Energy Plus, so it still operates on a very powerful software engine, but it's backed by some great labs. There's a lot of support out there. They recently launched their Unmet Hours Forum, so for anybody using it, I would highly recommend checking that out. Even if you're not an OpenStudio user, if you're an Energy Plus or Energy Pro user, it's a great database for troubleshooting. Responses are really fast by a lot of experts. It's a great resource. The great thing about OpenStudio is it's the front end, right? It's the GUI, the graphic interface, so that when you're designing an HVAC system or trying to model one, you have a loop that looks something like this. This may still look a little bit foreign, but you can set up a heating coil, a cooling coil, a fan, a set point, relatively, straightforward. These make sense, as opposed to trying to do this in Energy Plus, which is miles and miles of text and one comma that's out of place, and you're going to have to redo the whole thing. One of the downsides, though, is it's always catching up to Energy Plus, so to speak. Energy Plus comes out with new material, new HVAC systems, and OpenStudio has to play catch up with that. But it does have some additional features that Energy Plus doesn't have. Parametric Analysis tool, I'll talk a little bit about that, their results viewer, and their hand calibration tool. So I'll cover some of those advantages today. But it doesn't have as many HVAC capabilities. It doesn't have water-to-water heat pumps, ground source heat pumps, radiant wall heating. But it does now have low temperature radiant heating for ceilings and floors. So I'll talk about designing those. And just to give you a roadmap of where they want to take this tool. So they have kind of a list, the Google Doc that I linked on the slide is here. And this is their work tickets of all the HVAC systems that they have, and that there are work tickets to get into the system. And where they want to take this is, well, they want to expand their HVAC system coverage to catch up with Energy Plus. And then they want to extend the parametric analysis tool, so instead of just running all these different simulations, begin to use all of those to optimize your design. And so that's where it's heading, and it's going to be a kind of a bright future, although there may be some bumps along the way. So I'll start out just with constructing a radiant system. So you start by constructing your geometry in Google SketchUp. So this is SketchUp 2014. You've got your little Sophie here. Unfortunately, we have to get rid of her. And we can create just a basic floor plate. This may not be perfectly true to size, but you'll get the idea. So you select your surface, and then you have these OpenStudio tools, and you can create a space from the diagram. So we'll just create a one-story box for now. If we want, we can add windows. onto either of these walls, and they'll show up. So some great functionality there. So now we have a space. We do not have this associated with the thermal zone yet, and this is where a lot of people run into trouble. So go to your plugins, your OpenStudio user scripts, add or alter model elements, and then add your new thermal zone. And then we're good. So now this is associated with the thermal zone. So the advantage of SketchUp is pretty widely available. You can start taking your geometry from AutoCAD or something like that, your floor plates, build them into here, build your stories, and then associate them with thermal zones. From here, it's best to go into the OpenStudio tool itself, which is this guy right here. So, it always bugs you to save it as well, so I'll just save it as an untitled desktop or BSUG test. All right, and then we can start adding in our radiant systems. Takes a second to catch up. There we go. Come on. There we go. All right, so now we have our BSUG test OpenStudio model. We need to associate a particular weather file with this. You can download those from energyplus.gov, other places as well. And then we go into our zone. And so we have our zone named. We need to add air loops, zone equipment, and our thermostats as well. A convenient way to do this that is new with OpenStudio, that I want to highlight for any current OpenStudio users, is now they're really building up their measures features. So up in this tab, there's components and measures. So instead of what you would normally do, which is going into your plant loop and building in this piece by piece, your boiler, your cooling tower, etc. So we'd have to create a new loop and add each of our pieces of equipment in. Instead, we can do this apply measure now. We have to save our model. And these measures are found on the BCL website, Building Components Library, that OpenStudio is updating quite a bit, so you want to sync up with that. HVAC, we want to add in a whole HVAC system. And we'll use this office HVAC radiant with dedicated outdoor air system. And all we have to do is apply measure. And it takes a second to run, but this is still much faster than us building this by scratch. They have these for VAV systems, heat pump systems. We've had some trouble at the lab with the VAV system, but the heat pump has been great. So now we have 3 new plant loops. So we accept the changes. Have to reload the model.
I have a question real quick.
Yeah. Go.
Once you go into OpenStudio, I'm assuming you can't go back to SketchUp and change geometry, or can you go back and forth a little bit?
It's pretty much a one-way street. So you can update in OpenStudio and see those changes happen in SketchUp, but you don't want to be updating in SketchUp and here. So now we have 3 new loops. So we can look at our radiant hot water loop, and it added a boiler for us as well as a pump. And we can add in other pieces of equipment, set points as we need to. Okay. Now we need to go back to our zone and add in our zone equipment. So on the right-hand side, we've got our low temperature radiant, and these are new as of OpenStudio 1.1. So you'll need to be using SketchUp 2013 or later and OpenStudio 1.1 or later. And I'd really recommend 1.4 or 1.5 in order to have the capabilities of the parametric analysis tool. So we can add in our low temperature variable flow, And we also need a thermostat as well. So these are usually found in your schedules. And we'll just add in a typical office, medium office cooling set point for our cooling schedule, and medium office heating set point. All right, and there we have it. So much simpler than trying to do this by scratch. We still need to associate this with an air loop and connect to our particular surface, so that way we're not heating up the walls or the ceilings, right? And that can be a little bit tricky. Hold on. So we go to our facility tab. There's a time delay. There we go. Go to our building story and our particular space. Looking at our thermal zone. Oh, this screen is tiny. Sorry. This is also a great program to run on 2 screens as opposed to 1. You can here define all of your loads for the space and associate your particular surface for your walls and your floor, and this is what you'll need to associate, particularly your construction, to have it capable of doing with your radiant system. So I want to switch over to a slightly more complex model that we've done before that has all of this added into it. So here you can see we've got all our zones listed. We have our air loops and our zone equipment. If we go to our facility tab, you'll also be able to see which surfaces are controlled. So we have a radiant system in this building, several different loops, in fact, that are not the only thing that, not the only piece of HVAC in this particular zone. You can see that we have a supporting rooftop heat pump, which you'll see, you size your system for a particular radiant load, a radiant system, and then you can add in other systems to supplement that if you're afraid that of the thermal lag, occupant complaints, or overheating during the summertime, or overcooling during the wintertime. Okay. So that's kind of the 10,000-foot view of beginning to build one of these systems. And once we build one, then now we need to calibrate it, right? Model's no good unless we actually have something to compare it to. So I want to talk about that for just a minute. And so calibration, it allows models as a means of measuring energy savings, and the way that's commonly done is ASHRAE Guideline 14, which I'm sure a lot of the BSUG audience, particularly online, are familiar with. I took this straight from them, that their purpose is to provide guidelines for reliably measuring the energy and demand savings due to building energy management projects. Okay, so we construct this building, but we can't necessarily say we're going to save this much by switching our system or changing our set points if it doesn't actually match our building as it's currently operating. So within Guideline 14 are a couple of different standards to make sure our models are corresponding with reality and not this pie in the sky, how a building ideally would function, but matching an existing building to how it is. And that's the NMBE, which I always have to look up, the normalized mean bias error, and the CVRMSE, the coefficient of variation of the root mean square error. Basically, these are both different ways of measuring how the model monthly performance, electricity or gas demand is comparing with the actual building utility bills. So for a monthly calibration, this has to be within 5% for the NMBE, and you'll double each of these numbers if you're looking at hourly data. So if you're looking at hourly data, the mean bias error has to be within 10%, and the coefficient of variance has to be within 30%, because a lot more data, a lot more variance within that. It's usually easier to get a lower mean bias error than the coefficient of variance, just for a couple of different reasons. And you can calculate this. If you look up Guideline 14, they have the formulas, but it's also a pain having to do this in Excel when you export from Energy Plus and you get all of these hourly bytes or, say, monthly data, and then you have to type in this formula and then write in your utility bills and then go back and forth. And then anytime you want to make a change in your Energy Plus model, then you'll have to look at that change. So OpenStudio has a pretty nifty solution to that. And we can look at that here. So here's that slightly more complex model, like I just said. And one of the recent features of OpenStudio is on this very first globe tab, if you will, there's this utility bills menu. It says before utility calibration, you have to do two things. You have to select a weather file and select an actual calendar year. Because usually for our weather files, we're looking at a TMY file, a typical meteorological year. Well, that's great for maybe predicting how a building will perform over time, but if we're trying to calibrate, we need actual data. We need an actual meteorological year, an AMY. So I have one of these for Boise, so I'll just plop that in here for 2014. And we need to make sure that we have the right calendar year as well. You don't have to put in the starting day or anything like that, but this way it gets our weekends right. It gets, when Easter happens, which I always forget, but your building's going to be unoccupied during those times, and if you don't have that in your model, you're going to get a higher error. All right, so we set up both of those. Go back to our utilities bills, okay, and here we have our electric utility bills. So for simplicity's sake, I'm going to start with just an all-electric building. We add in this little plus here, and we'll have utility bill number 1. And I'm just going to add a few new billing periods. So I'm just going to do half the year. And so this is when, if you're analyzing a building, you either ask the building owner or you make a request of Idaho Power to please send us your data. At the very least, you can just take your straight-up bills and look at your energy end use, and that's what I'm going to approximate right here. So for January, this hypothetical building used 1,300 kilowatt hours. February, 1,200. March, 1,100. Another thing to note while I'm doing this is it's a good idea to save this frequently because you can see there's a lot of processing going on each time I do this, and if it crashes, then it takes a while to re-enter this data. The nice thing is you only have to do this once. And 2 more. So for June, it was 1,300 kilowatt hours, and July, I have a 1,400. You can also put in your peak, and we'll be able to measure that as well. So once we have that entered in, we have to save. And Chris, yep.
One thing that make sure you pay attention to what the dates are on the bill all the time, all along. So it may not be start date, so I want to write up with what the date is bill rather than using the month that is identified. Usually that's a month later. It's actually that compared to real web data, you really have to.
Okay, thanks. For the people online that didn't quite hear that, be sure you're looking at the read data, the read dates on each of your bills as opposed to just the billing date. Okay. With that entered in, we can go ahead and run our simulation. Hopefully it will. In case it didn't, and for sake of time, I have another building that I've already got in here, pretty similar to our last one. And normally when you're looking at your OpenStudio results, this is the screen that you'll see. For electricity consumption, and if you have natural gas for heating, you'll see your natural gas consumption as well. Pretty similar to your Energy Plus output. The new feature here that I want to draw your attention to is this calibration tab. And they have two different methods, the Federal Energy Management Plan, which I'm not too familiar with, and then the ASHRAE Guideline 14. And here, nice, easy to read interface here. You've got your coefficient of variance as well as your normalized mean bias error. You can see your model in blue and the actual building consumption in green. Okay, so this is great, but we're still pretty far off, right? This is way off of our actual, what our standards are for calling this model calibrated to this building. So you're going to have to start changing different variables within this. It looks like we're doing okay in the shoulder season and tracking a little bit with the summertime, but there's something really wrong during the winter time in terms of our heating. So we're going to have to look at our boiler efficiency, if we have a boiler, our furnace efficiency, perhaps it's something with our insulation. So as opposed to doing that one by one, running this again and again, we can now utilize or take advantage of the Parametric Analysis tool. So with the Parametric Analysis tool, go ahead and launch that. All right. So this is the new feature with OpenStudio 1.4. This is just a getting started menu. There's several YouTube videos and online support for using this, but it's extraordinarily powerful. You can run this either locally or on the Amazon cloud. You can rent a cloud of servers for, I mean, it takes $4 to run maybe 2,000 simulations, and it's just a ballpark. Don't necessarily quote me on that, but you can get a lot of power out of that pretty cheaply as opposed to one poor laptop that's trying to do all of this, which is why I've run these in advance. You don't have to sit and do that. But we'll just create a new project here. I'll enter BSUG test. And just create a folder of where you want this to be. Oh, I already made one. What's that name? Sorry. All right, and then it takes us to this menu, and this is where we import your baseline model, the model that you just created. This isn't necessarily your calibrated baseline. This is the model that you're starting with, and you're going to tweak in order to perhaps meet your calibrated baseline. So browse, and in desktop, let me see, maybe baseline. You kind of have to say a prayer at this point. It does crash from time to time. I'm 3 for 4 on this so far today, so hopefully we'll come together. It doesn't like it if you go from 1.5 to 1.4 and vice versa, so be mindful that you're staying within the same version. But good success, all happy now. And now we can start looking at different measures that we want to change. And this can be the form of the building. We can even change its orientation. So if our window was on the north versus the south, we can make a change there. Our window types. And I have very few of these loaded in, but you can find all of these on the Building Component Library. By category, so for opaque, these would be our walls. You can set the R value of insulation. For HVAC equipment, this is particularly important for radiant systems. You can look at your set points by degrees, your schedules, and this is going to make a really big difference. That's one thing we've noticed in one project that we're working on right now, is there's the default schedule that Energy Plus runs, which is wildly different than how the building is actually run. And until you start kind of breaking that down by hourly and start calibrating that model, that's not something that's going to be immediately apparent. So start playing with your schedules, but as opposed to doing that one at a time, we can do dozens at a time. For a simple example, I just downloaded changing the R value of the exterior walls. So we need to add that in. Just drag and drop. And click on this, and this is where you can change your set points. And you can either set this up by increments, or you can say, well, I want one that has virtually no insulation, like R2. And we'll just duplicate this a couple of times and say, well, what if it was R20? And what if we have a super building of R, I don't know, 70? Then we can look at how each of these is going to affect that energy signature and consequently what this is going to look like. And in addition to that, instead of just changing one variable at a time, we can add in other measures at the same time, looking at our HVAC controls, the furnace efficiency, etc., and see what each of these effects and combined effects has on our model. Okay, we have these in. Once you have these set, you don't want to go back and forth in this toggle menu. It's kind of a one-way street. Once again, there's a warning that they stayed on that as well. All right. And for these measures, I'm going to just select all. And I'm going to create one for each selected measure. So this is one run for each of the different measures that I talked about. Then we can either run locally on this machine, or we can turn on the Amazon cloud. To be honest, I haven't gone too far into the cloud feature. That still scares me a little bit until I'm fully confident on running locally. But this is still a great feature. So I'll jump to, so we hit run. These will all start going. It will show 0% completion for pretty much a long time, and all the models will finish pretty fast on each other's heels. So even if it says that it's 0% complete, you'll see that these will be running. Hit start. And so just pay attention to that. So since this is a 4-core machine, I've got 3 going and one that's going to wait in the queue until this one's complete. All right. So once we have those all run, so this was looking at that previous building that I showed, and I changed the R value back here to an R value of 1 at one extreme and an R value of 30 at the other extreme, where our initial model was at R13, somewhere in between. And this is the standard view, but now they have this nice calibration view where it calculates your normalized mean bias error and your coefficient of variance, not only for your baseline, but you can compare to how it's changing each of these measures, or each of these models that has these measures applied to it. So you can say, okay, reducing the insulation did nothing for me, right? The same error. Whereas reducing it, or increasing our insulation rather, has reduced our calibration error a little bit. It's not as visually comforting, perhaps, as this, but what you can do is you can now take your seed model, which will be in your project folder once you create this. This will exist in a project folder here, and here's your seed model that you can then open up again in OpenStudio back to exactly where we were before. Only this time you have the information to know that, hey, measuring this particular run here, which in our case was increasing the insulation value, had a really good effect. So we should do that to get our building tuned in. And once we tune that in, then we can, start tweaking other parameters and kind of dial in our unknowns and work on calibrating our model. All right. Are there questions on anything before I kind of head back into the PowerPoint? Yeah, Alan?
I guess we can see it here, but my question is, how does the parametric run change the building form, and what is the extent of changes that can be automated?
Changing form, that is a good question. I haven't explored that. I know that you can change window-to-wall ratios, so you can change the amount of fenestration very quickly, as opposed to manually doing that in SketchUp, going back and forth. So that's one advantage. Chris?
So when it comes to calibration, where you're kind of walking through envelope measures to potentially try and dial that in, what, from your experience, are some of the most typical, or the types of measures that you tend to start with first to try and calibrate in addition to envelope measures?
I'm still new at this, so still learning, but I would say set points and schedules have been the main. Lights that are supposed to go off on the weekend that don't, set points in the building that change, unoccupied offices that are supposed to be off but are still on. Getting a handle on those is really important. All right. So I kind of want to wrap up with some lessons learned on this so far. So despite the much easier interface, sorry, I'm getting a little bit of feedback. The easier interface of the OpenStudio to Energy Plus code, it's still not all that easy. And designing a complex HVAC system in a simulation tool is still really hard and still very time consuming. It's getting better. There's light at the end of the tunnel. OpenStudio is putting a lot of resources, and I should say NREL and LBNL on behalf, are putting in their resources into making this easier. But it's still not quite as easy as setting up a simulation with a packaged rooftop unit. The visual calibration in OpenStudio, you still have to put in, this is only for monthly, and it doesn't get into hourly calibration, and you still have to put this in by hand, so that's why they're calling it their hand calibration tool. But it gives you a really fast feel for how your model's performing versus how the actual building is. And you can kind of visually get a gut instinct on, oh, hey, this is happening during the summertime as opposed to the winter. I should be looking at my cooling system as opposed to my heating system. The parametric analysis allows for rapid testing of a whole bunch of different variables at once. This is something that you can set up in your office and run overnight, as opposed to sitting and trying to ping one piece at a time out of the Energy Plus code, or changing one building feature in SketchUp at a time, and can really speed that process up by quite a bit. So much so that it's beginning to get into the realm of optimization, where you're in the design stage as opposed to the end stage, if you will, and you can run thousands of simulations to figure out the optimal orientation, the optimal HVAC system, and so on. And this is really what OpenStudio is pushing. Rob Guglielmetti talked a little bit about this a couple months back. Really, really exciting stuff, and that's where it's headed. And it's not simplifying this necessarily, right? It's not saying, oh, we're going to take this down to a very coarse refinement so that we can pump this out. It's still operating on the Energy Plus weight, I guess, but you are getting a lot of extra power from the Amazon cloud, or if you want just a server bank at your office. So that's where it's heading, and it's kind of exciting being on the learning edge of this. Still a lot of issues to be ironed out, but it's been fun. So started a little bit early, ending a little bit early, but I've got lots of time for questions. Yeah. Tim.
I guess in our experience with OpenStudio, we found the controllers to be somewhat limited, and there's always some limitation. Even in the BCL library, a lot of times they don't give you a lot of information on what's in that script. I'm curious how you dealt with that workflow as far as writing Ruby scripts, or if you were going to Energy Plus and back, or how you did that work.
Yeah, so for this, the particular project I'm working on in this Radiant system, I actually had to take it into Energy Plus because I'm not a Ruby scripter. But that they're trying to make that more open source, more available. They have a measure writing guide that is great. And so if you know how to program in Ruby, then you can start writing your own measures, and you're not limited to the BCL, the library that they have online, although they are adding to that every month. And it's not just NREL that's adding to that. It's firms across the country. But our very own Alan back there that's running IT is currently working on writing some measures for us. But yeah, you're right. Controls are tough, particularly. There's some schedules that you can alter in here, and I've been able to do that. But yeah, there's still a little ambiguity in terms of how their measures are operating in skill area.
So is it easy to switch back from Energy Plus to OpenStudio, especially when it comes to set point managers? Because I run into that problem where you can only find them in Energy Plus, and you want to switch them, you want to come back to OpenStudio, and how are you able to walk around that?
Yeah, great question, something we've been dealing with a lot. It's very easy to export from OpenStudio to Energy Plus. Coming back is a lot harder. You can get 90% of it, I'd say. You can get the geometry from Energy Plus. You can get the schedules. You can get lighting and plug loads, but it really doesn't translate HVAC well. And so what we've done before is actually take our Energy Plus script, find all of our branches, and just eliminate our HVAC, import that into OpenStudio, and then rebuild it there so it's kind of OpenStudio friendly, if you will. So a lot of work. So if you can stay in OpenStudio, that's great, especially to have the functionality of Parametric Analysis tool, but it's something where we've had to go to Energy Plus to get some of those HVAC features and some of those controls that OpenStudio hasn't quite caught up to yet. So it is on their docket. They're hoping by December 2015, or no, December of this year, I believe, to have another round of HVAC measures out. Sheree?
So now with the parametric analysis tool, you can only import OSM files, right?
Yes. Yeah.
You can't import IDF.
No, you would have to import an IDF, turn it into an OSM, and then run the parametric analysis tool.
Okay. So if you left OpenStudio
to go to Energy Plus,
with Energy Plus to stitch in some HVAC systems that are not supported by OpenStudio, you cannot go back.
No,
you the parametric analysis
lose
tool.
that. So you would have to do your own Ruby script on that.
Okay. Can you build water source heat pumps in OpenStudio now?
Yes, you can. Water source heat pumps. It's just not the water-to-water heat pumps. There's water-to-air heat pumps.
Water to air. Okay.
Yeah.
Nice.
Yeah.
We have a couple online questions. Okay. I'm going to start with the second one. There are various radiant systems are coming up, for example, false ceilings, floor and wall. Is this applicable for all, or are there any design constraints within OpenStudio, I'm assuming?
So design constraints within OpenStudio. Trying to understand that a little bit. One of the design constraints is that you don't have functionality for walls, and I know there have been some issues on the radiant ceiling panels, but they do have the option where you're defining that coil that can be for heating or cooling, that you can designate that as either a ceiling or a floor slab. And one of the options that I'm particularly excited about with my research is taking this into OpenStudio and then writing a measure that will change the thickness of the slab and then run a parametric analysis on it to look at the change in thermal lag and occupant comfort.
Okay, and one more, and we're not sure about this one, so we'll see what you think, Damon. But,
okay.
I have calibrated a model matching demand first and then energy use. Shouldn't we focus on variables dealing with kilowatts first before energy use related variables? In other words, changing the fraction in the schedule rather than the number of hours. Do you have an opinion on that?
I do not have an opinion on that. No, it sounds like something I would like to follow up on. Yeah.
So have you, if we just go back to the calibration page where you can put in the usage and the demand, have you looked at demand much, or have you mostly been going with the use?
I've been focusing on usage, but for a project you want to have both.
Yeah, doing both sounds good.
But
But
the
it might be
simplified one,
something.
it was just trying to, so you didn't have to watch me type however
Mhm.
many numbers. Yeah.
Right. But that might be something they're suggesting, is to look at demand first instead of energy use first, which I've not done. So thanks for that. Oh. Can you model double skin facade in OpenStudio?
I don't know. That would be a question for the unmet hours forum. Type that in, and I'm sure you'll get a response very quickly. Yeah, I think Chris had a question.
I think eQuest has some parametric modeling capabilities as well. Have you worked with those, and how does that compare? Okay.
I haven't worked with eQuest much.
Okay.
No. A couple exports, and that's the extent of it. Yeah. Okay.
Any other questions out there? All right. Do you have a question? No?
Yeah.
Okay. Well, unless Damon has anything else, we'll call that a day. And thank you all for coming. Again, next month, anyone who wants to join us here to watch remotely the Portland Building Energy Simulation Forum presentation is welcome to, and we'll get you some lunches for that December 17th at 1 p.m. to 2 p.m. So thank you all for attending, and we'll talk to you soon.
Thanks.